A very good morning to all of you. Welcome to the session 10 of Atal FDP. Today, we have among us Dr. P.K. Tiwari, Assistant Professor, MNNIT Allahabad. The title of his talk is Wind Energy in the Context of Current Electricity Markets. A brief bio about Dr. P.K. Tiwari. He has received his BTech in Electrical Engineering with honors from UP2 Lucknow, UP, India, MTech Power Systems from National Institute of Technology, Hamirpur, India, and PhD in Electrical Engineering from NIT, Hamirpur, India. His research interests are in the area of facts, power system, sector deregulation, and electricity markets, assessment and mitigation in renewable energy integrated power markets. He has guided 4 PhD students awarded their PhD degree and 16 MTech theses under him. He has published more than 80 research papers in various reputed international journals, national magazines, international and national conferences. He has been conferred by prestigious POSCO Power System Award for his doctoral thesis research work. Currently, he is working as assistant professor grade 1 in Department of Electrical Engineering, MNNIT Allahabad, Pragyaraj. He has about 8.5 years teaching and research experience in MNNIT Allahabad and NIT Silchar. He has handled various administrative positions at NIT Silchar and MNNIT Allahabad. He taught many power system, electrical engineering and allied subjects for BTech, MTech and PhD students. He is a member of IEEE, IEI, IASI, IACSIT and IAENG. He is a reviewer of various reputed international journals such as IEEE Transactions on Power Systems, IET Generation, Transmission and Distribution, Electric Power Components and System, Taylor and Francis Group, Renewable and Sustainable Energy Reviews elsewhere, Energy Policies elsewhere, Renewable Energy Focus elsewhere, International Journal of Computers and Electrical Engineering Elsevier, Journal of Renewable and Sustainable Energy AIP, and many more. Sir, we are truly honored to have you for this session. And now I would kindly request Dr. P.K. Tiwari to carry on his session.
Thank you, ma'am, for this nice introduction. A very good morning to all of you. Madam, can you please?
Morning, sir.
Yeah. Okay, let me share my screen. Please confirm whether it is visible to you or not.
Yes, sir.
Okay. Thank you. So, very good morning to all of you. And I would like to thank you for the coordinators of this Atal FDP for just giving me this opportunity to discuss something in this platform. So, topic of today's discussion is wind energy in the context of current electricity markets. So, I know this is the 10th session of this particular workshop or FDP, and you might have gone through various experts in the various what means uh, concerned areas, and you are familiar with the many things related to the sustainable energy and its use and its applications and other things in the Indian context. So here, I would like to emphasize the wind energy, especially in the current electricity market, and why this topic is important. That we all know that wind energy is having a large potential to contribute for any countries uh, in the power management and power feeding issues. So we all know this particular fact that why wind energy. So I'm starting from this first milestone, that why wind energy. Okay, and we all are very much familiar with this particular fact, why we need the wind energy. But here, in this discussion, I would like to just emphasize its applications in terms of electricity markets. And there are two issues with this wind energy and converter system. If we can see, uh, one issue is associated with uh, maintaining the wind variabilities. That is one of the issues. And another issues, one, uh, once we are integrating the same with the grid, then the uh, what are the issue that need to be resolved at that particular point, that is important for all of us. So the integration issues are having, again, there are many sub problems, like if you are integrating the wind energy with the existing grid, then uh, what to do from the your plant side, or from the converter side, and from the wind conversion system, you need to just go through that. And another side is the grid side. So when we are considering the grid side applications of wind energy integration, then we have to again go for the two sub, what you can say, the areas. One area, when you are integrating the same in conventional system, and when you are integrating the same with deregulated power market or deregulated power system. Okay, so here we will see the differences between this the conventional and the deregulation structure, when we are going to interact this particular wind energy into our power system. So all these four points are well known to uh, all of you, so I'm skipping this. Now, basic key cost components of wind energy. Since I am discussing the issues related with the wind energy in electricity market, so cost is the major concern when we are talking about the electricity market. All right. So my discussion will be limited to the financial discussions, financial or cost related issues, or cost related risk issues in electricity market. So here, if you will see, mainly if you are going to install the wind energy, the major component is its installation cost and operation and maintenance cost. All right. So there is no any fuel cost associated with the wind energy. All right, but if you are producing some energy from the wind, and it is going to contribute in the grid, then obviously it will affect the price of the power available on the grid side. All right. So in terms of electricity production, or whatever the energy losses can be covered, or energy losses can be varied by using the wind energy, that will also affect our grid operations. All right. So if you will discuss, the main thing is the turbine. Okay, so if we are integrating the wind energy, then we have to decide how much cost will be incurred when we are going to think for a particular capacity of the wind power plant. All right, so here we can see that approximately 75% of the total cost of energy for a wind turbine. I'm talking about the turbine here. Okay, so 75% of the cost is related to the upfront cost. The upfront cost means that is the cost incurred while installing the wind energy, particular power wind power plant. So the cost of the turbine associated with that, then foundation, electrical equipments, grid connections, and so many things are associated with this particular cost. And approximately, if you can see, it contributes 75% of the cost associated for this particular wind turbine. So we have to see the feasibility, we have to see the capacity, we have to see the other market based, what you can say, the feasible things for installing the wind energy when we are thinking for that. Next is the fluctuating fuel cost have no impact on power generation cost in this particular case. If we are talking about the wind energy, then like conventional power plants, we don't have any fluctuating fuel cost effect in our system. Okay, so this particular thing separates this wind and renewable energy based system from the conventional system. And when, since we are talking about the cost and profit in electricity market for all the market participants, whether it is from the generation side or whether it is from uh, uh, the distribution side or demand side, you can say, or any other market participants, you can say, for everyone, the economic or profit is the very important factor that we need to take care when we are going through the electricity market issues. Next is the wind turbine is capital intensive if you will compare the same with the conventional fossil fuel based technologies, whereas 40 to 70% of cost are related to the fuel and operation and maintenance. So we all know when the fuel is being used in a particular source, then its operation and maintenance cost will be also in proportion to that. And wind, if you are using, then at that particular point your whole focus is towards maintaining its variability or intermittency. Okay, so many, you can say, large amount of research issues have been identified and addressed in the past for taking care of the integration issue of the wind uh, plants to the existing grids. So if you can say the other cost components like land rate control system, underground cabling, road construction, etc., they all will come together, and this will be what uh, common, that is the installation cost that will form, and this will be a kind of one-time cost. And the one-time cost incurred in by installing the wind power plant, and its lifetime need to be taken care, and we have to consider its what contribution in the grid for this particular cost aspect. Okay, next is the investment cost considerably varies between countries. So if you are talking, I told you the geographical area is very important when we have to install a particular wind turbine. Then we need to see the particular point of installation and its feasibility. Just now I told you the feasibility is very important when we are going to install a particular wind power plant. So this will be varied nationwide. So if you can see, there is a need to determine how much CO2 and fuel costs are avoided from wind power investment. All right. So we have to see the wind power plant and its lifetime, and we have to see how much power will be contributed by the wind power plant to the existing grid, and how much CO2 is being reduced while introducing the wind power plant in the system. Okay, because if you are going to integrate a wind power plant, then it will directly affect your power costs in the grid side. Okay, so that we need to address when we are going to discuss about the electricity markets issues. Here, figure that has been referred, okay, it shows the main components of a wind turbine, and their cost share, okay, percentage cost share, and this is for a 5 megawatt wind turbine that has been referred from a magazine. So if you can see the cost of each and individual part of the wind turbine, here you can see the tower is having highest contribution. If you can see the tower, so the length of tower, okay, that is important. It's a structure, okay, and where you are using this particular tower, that is also important. So if you can see the major contribution, major percentage of the costs will be contributed from the tower end. Then the rotor blades, if you can see, its contribution is approximate 22.2% of, if you are contributing the whole what share of the wind turbine. Okay. So next is the rotor hub. If you can see the many small contributions for rotor hub, rotor bearing, main shaft, main frame contribution, gearbox, generator. Okay, and so many things are associated with the wind turbine, and we have to see its contribution when we are going to decide the installation cost of particular wind turbine. Okay, so the point is that if we are dealing with the grid operations, and we have to deal with the dispatchable power under these circumstances, how this installation cost is going to affect our system. So yes, it is a one-time cost, and we have to see it as separate as one-time cost, and we need to assess its effect, its variability effect in the power market, how its wind variability is going to affect our power market specifically. That we need to take care. All right. So these are everybody is requested to please mute yourself. I request everybody to please mute yourself. Thank you. So again, the operation and maintenance costs, it includes the insurance, regular maintenance of the wind turbines, now repair, spare parts, administration, all will means all are the day-to-day work associated with the wind turbines. So they need to be considered, and while operating the wind power plant, then operation maintenance costs is important, and we need to take care about that also. Now the major issue is the impact of wind power and electricity demand. So we all know the variable nature of the wind turbine. When we are going to interact, obviously it will be difficult to uh, maintain or to direct the power that is coming from the wind power. We don't have any means what power to just handle the wind as per our own wish. Okay, that we know very well. Okay, so that is the one issue, and we need to see its effect. And another thing is the electricity demand. Okay, so if we are looking towards the electricity demand, then we have to just go with the very perfect, very efficient demand side management for addressing the market, so many market issues in the electricity power sector. Okay, so if you will say the wind power normally has a low marginal cost, or since it is having zero fuel cost, and therefore enters near the bottom of the supply curve. If you will draw a supply curve between the quantity of the supply versus this time, if you will draw the or you can draw the graph of price versus power, then what you will see, your supply curve will be uh, just increasing curve. It is increasing curve and moving from bottom towards top. Okay, so what will happen, since the wind energy is having low marginal cost, so therefore uh, if you will represent the same in that combined or hybrid supply platform or curve, then it it will be situating at the bottom of the supply curve. So what will happen if it will be situated at the bottom of the supply curve, then it shifts the supply curve to the right hand side. Okay, and if the supply curve will be shifting at the right hand side, it will result a lower power price. So that is also clear from our what you can say the concept associated with the wind, that if we are introducing the wind, then we need to wind with what we can say, it is not like a small amount of wind, that is the considerable wind I am talking about. If we are interacting the considerable wind power into the grid, then obviously we need to decrease the power from the conventional sources. And when we are decreasing the power from the conventional sources, our cost or power price will be decreased accordingly. So if you will see, the cost curve will be moving from left to right, then if you are considering the electricity market, then here we need to take care about two different factors. What are those factors? First is that whether your demand is elastic or not. Okay, whether it is fixed demand or rigid demand, or it is elastic demand. Okay, so if you are considering the rigid demand, then also this cost will be decreased considerably. And if you are considering what you can say the elastic demand at the another side, then it will have another beneficial effect, because if we are making the demand flexible, if we are making the supply flexible, if both are flexible, then we need to go at a common point as per the market, what you can say the safety, market efficiency and market reliability need to be taken care, and then we need to decide a market price for that. So I was saying that it results a lower power price. It will be depending upon the price elasticity of the power demand also. So generally, the price of power is expected to be lower during period with high wind than in period with low wind. Okay, so it is the well-known fact. So this is one effect I would like to emphasize here. Another is that if suppose we are generating the considerable amount of wind and we are going to interact it in the system, then what will happen? uh, there may be congestion in power transmissions. Okay, because instantly you are not going to decrease the power that is coming from the conventional power plants. So wind variability, what you can say the wind pattern you can predict from your side, and you need to follow up at the real time basis. All right, so there may be a congestion in power transmission when we are interacting the considerable amount of wind at a particular time. Okay, so especially during the periods with high wind power generation. Okay, so if available transfer capacity cannot go with the required power export, the supply area is separated. So some corrective measures we need to take from our side, because there is a specified path, a specified quantity, everything is specified
अरे हाँ
beforehand,
आज फिर इंटरव्यू है
and
ना
in the day ahead
12
electricity
बजे
market, and on that we are proceeding with. And
हाँ
again I am repeating, please
अच्छा
mute yourself, everybody is
कहाँ पे
requested to please mute yourself.
हाँ है ना कहाँ पे क्या काम करते थे
So yeah, so okay, so the supply area we need to separate from the rest of the power market. So this wind energy, this supply cost curve, we need to separate from the existing combined power market, and it constitutes its own pricing area. All right, that's why we need to take care whether the generated power we are where we have to just push this power generated from the wind. It is directly towards the specific load, or it is what what will be the root of that power that we need to take care, what will be the integration point, and where the power will be flowing, that we need to take care. So we have to do all this exercise beforehand in what if we are saying in the day ahead electricity market. All right, so everything is based upon whatever we are predicting. Okay, so our predictions should be uh, uh, efficient, so that we should get less variations at the real time basis, and then we can handle the situation that will be arising at the real time basis. Okay, so uh, these two effects can be seen when the immediate wind power can be integrated in our electricity market. Now, electricity wholesale markets are undergoing rapid transformation. Okay, we all know. And if you can see the worldwide electricity market, and if you will study the worldwide electricity market, then you can see the various kinds of models have been adopted, has been developed by several countries, and they are adopting their own model to manage the electricity market. Now, the concept comes from the conventional side towards the smart grid side, or you can say we are dealing with the microgrid concepts here. Okay, and we prefer to choose this microgrid operations when we are going with the any renewable energy based generations. Then your microgrid will be very important. What you can say, the platform where we can manage the things, where we can handle the things, and it will be in standalone mode, or it will be in grid connected mode also. All right, so if you are talking about the wholesale electricity market, so it is having a huge transformation worldwide. Okay, why it is so? Previously, the renewable energy based generations were less. If you will see the 15 years back, and you can see at the current situation, then what we can see, the renewable energy had been increased drastically, and they are contributing considerably in the power of a particular country. So, since they are sustainable in nature, then we need to take care, even they are intermittent in nature. Okay, then we have to adopt them. Okay, because they are the future of the electricity. All right, so the wholesale electricity market is also going to affect by the high penetration of renewable energy sources. Not, I'm not talking about only the wind energy. At this particular point, I would like to emphasize the other renewable energy based sources, those who are means dependent upon the nature, and the nature is directing towards the power that to be received from the particular source. Okay, so the effect of wind forecast and demand forecast error. So I told you just now, we need to make our forecast better by using a particular forecasting techniques. Okay, and we need to what forecast in such a manner then this real time and the actual forecasting, what you can say, the forecasted value and actual value, that must be equals to zero. Okay, but suppose due to any reason it is not having zero, it will be affecting the power market and its price. That I want to explain here. All right, so if any variability can be seen, any variability can be highlighted in the real time basis, it will be going to affect directly your electricity market. Okay, so if you can see how this price risk can be seen. So the wind forecast errors may affect price spreads in area with large shares of wind power generation. Okay, so here I am emphasizing the fact for large wind power generation. Okay, so because if you will consider the large amount of wind generation in megawatts, then it will be definitely affecting this and dealing with this price factor. Next is the demand forecast error. Okay, it may impact on almost all prices spread except in area with relatively low consumption. Okay, so what you can say, we have to identify if we are dealing with the wind forecast and we are dealing with the demand forecast. Okay, if by any means we will be able to make them efficient, then obviously we will make the electricity market a balanced market, a stable market, a reliable market, and in terms of their means economy associated with the market and its participants. Okay, so we have to see this demand forecast, and we have to identify where the demand, where the high demand is there and where the low demand is there. Okay, so that area we need to specify, and accordingly we need to proceed for their forecasting. All right. So the markets closer to real times are becoming more important. Why they are becoming more important? We are talking about the real time variations, real time price variations, real time market behavior variations, when we are going to consider the intermittency of the wind power, especially. Okay, so if so, what it reflects, the real time market is having most important when we are considering the intermittent renewable energy sources. Okay, so you might have heard about this. When we are dealing with the electricity market, then we need to establish the market, we need to clear the market one day before. Okay, and it is possible only when the uh, forecasted things will be presented before the market participants, so that the market participants can take the necessary action from their side, and they can participate accordingly to maintain this balance. All right, so the market closer to real time are becoming more important due to the increasing shares of wind power, and their role as reference prices relevant for price risk hedging, capacity market, and other decision making will probably increase in the future. So what are the price risk hedging tools are there that we need to also take care about, and because ultimately we have to see the variability effect on the price. So ultimately it will affect the price or economy of the electricity market. So that's why uh, intermittency can be reflected or can be dealt in terms of the price. So we need to put various price hedging tools, mechanisms are already present. uh, you can go through that, and you can find how we can hedge the price in the electricity market in the variable time. Next, if you are dealing with the real time market, we are discussing here about the real time market. So it may be 5 minutes before of implementing the market, or it may be at the real time basis. Okay, whatever it is, but obviously the time duration will be very very short as compared to day ahead. Okay, because day ahead need to be established 24 hours before the execution of that particular market. All right. So, what this question may arise in our mind, can we say that trading activity is shifting from the traditionally dominant day ahead market into the market closer to real time? Is it true? So, answer of this question is yes, but not completely. We are shifting from the day ahead market to the real time market, uh, but day ahead market is having its own importance. Okay, everything we cannot do at the real time basis. Okay, so we need this day ahead market establishment even for supporting the real time market. All right, so what we can do, we should not assume that day ahead market becomes useless. Okay, because we are not dealing only with the renewable energy sources, we are dealing with the so many other conventional sources and dispatchable power and that they can be dealt effectively when we are going with the day ahead, uh, what we can say, day ahead efforts. So we should not assume that day ahead market becomes useless. It will be definitely a major role in the functioning of the future electricity market. Okay, so the day ahead electricity market and the real time market both are having their own importance, but what we can say, if our forecasting plays a very important role here, if our forecasting is good, if our forecasting is efficient, then even in day ahead market is can be considered for this intermittent renewable energy sources. Otherwise they can be considered in the real time basis also. Okay, so both are having their own importance that we need to remember. So instead, what we can do, we should think that intraday and regulating power markets are play a more relevant role as whether dependent production becomes more dominant in the production mix. So obviously, there power coming from the renewable energy based resources, those are called the dependent productions. Okay, and we don't have any control on the production. Okay, so obviously in the future they are more dominant when we are considering the conventional as well as renewable energy based hybrid system. Then we need to take care accordingly. So once the day ahead market is closed, so what we can say here, once the day ahead market is closed, the intraday market continues trading till 1 hour prior to the delivery hour. So it will be better to just plan for before 1 hour, before execution of the particular power market, and we can see the variability effect at the same day. Okay, when the market to be executed at the same day, we need to take care about the variability. We need to consider this variability, and uh, then we have to proceed for that. It allows market participants to address errors in their demand and supply forecast. So what I told you here, that uh, something that we forecast from our side and something we can see at the real time basis. So what we can see, if the forecasted value, there are two chances whether the forecasted values will be more than the actual values, or actual values may be more than the forecasted value. So what we can see, if both the things are what you can say, they're not good for us, because if we are predicting something and even we are getting the actual value more than the predicted value, that will also going to affect our market. So it will create an unbalance in the system, and then it is what in terms of electricity market, we need to represent them in terms of imbalance cost. All right, so imbalance cost is a term associated with the renewable energy based intermittent sources and their forecasting errors. Okay, so if the actual is more than forecasted, then what will happen, and if actual is less than forecast, then what will happen. We need to take care about these two particular things, and they are directly going to affect our power market. Okay, so we need to reduce the error from our side. We need to means from our side means not you can say as a customer, uh, but it is in terms of what you can say, the market operator, system operator, and those who are dealing with the system market at the leading role. They need to take care about those issues. And obviously, if you are a market participant and you are going to participate in market participant, whether as a generator or from the demand, you should have your own strategy. Okay, it is not like that whatever has been planned by the system operator. Yes, obviously you have to follow whatever has been scheduled by the system operator, but you should have your own strategy from your side, that if you are going to participate with the already demarcated things, then how you can earn more profit by doing so. So, since this contribution game is for owing the profit also, so this particular time, this part is important from the participant side. Okay, so this need to be taken care. Next, that is the major risk due to wind. As I told you, when the wind is varying, then there will be a price risk originates from the uncertainty about the selling or buying price of the electricity in the future. Okay, so the price risk will be imposed here. Okay, that we need to take care. And another is the volume risk, because if we are going to predict this much amount of power will be available from the wind, and the forecasted power forecasted value is not true, it is different from whatever the actual value we are getting, then this kind of risk is called the volume risk. Okay, so the volume risk and price risk, they are associated to each other, and when one occurs, it will affect obviously to the another one. Okay, so the increasing amount of wind impact both risks, because by its nature, weather dependent and intermittent generation includes uncertainty about the generation volume, which impacts price volatility and therefore the price risk. So price volatility is the main thing that we need to emphasize. Like in electricity market, if you will see the past 15 years research, then you will find the many efforts have been made to find the way to minimize this price volatility, because if we can stable just or and we are closer towards the stable value, then we can say the risk is less as compared to that. So, in our further discussion, we will discuss about this financial or economic risk also. So, now, in terms of Indian scenario, since your this FDP is emphasizing this sustainability behavior for the Indian context, then in that particular what you can say the context, I want to discuss something from the policy side, whatever the policy has been adopted from the government of India to promote this renewable energy based resources in our country, and also to promote the what you can say the large potential power plants, renewable energy based power plants like solar, wind, etc. Okay, so if you can see the Indian renewable energy based policies, then you can see a drastic growth in in year 1994 to 1996, and this particular duration is called the period of wind power rush in the Indian history. Okay, so as Indian wind market saw an excessive growth at that time, because there was drastic increments in private investment. If you can see with this duration, the private investments were more, and why they are more, then government have announced some means what uh, for their benefit, government we are having some policy, that's why the private investments were more, and drastically the wind power amount was increased in our country. So uh, you can say it is due to the zero tax planning opportunities to the private investors from the government side. So the growth in wind energy sector slowed down after 1997. So if you can see, this growth is still continuing up to 96. It was at peak, and up to 97 also, even it has been continued. And as the investors visit Indian wind market as a tax saving investment went through a major shock. What major shock they got? Okay, as government proposed to impose a minimum alternate tax of 12.9% on them. Okay, so Previously, it was at zero tax planning opportunities. Now, a tax has been imposed at 12.9%. So, it discouraged the private investments at the time, and that's why this growth had been decreased by some what you can say means value at the 1997. So the profit from marginal tax credit was also reduced to 35%, and previously it was 43 to 46%. So you can see government has pushed, promotes the energy at that time, and then when tax was imposed, then it has been decreased. What further steps has been taken that we can see? You might have gone through the Electricity Act 2003, but you can say uh, it is a Bible of electricity power market, you can say, in our country. Okay, like because in this Electricity Act 2003 only, the government had given this opportunity to grow the power market, and what you can to facilitate the available participants to come and participate in the power market and take the benefit of that. Okay, so the Electricity Act 2003 proposed the feed-in tariff for renewables in the country, and uh, to provide a guaranteed price, that is above market price for producers. Okay, so government has imposed this feed-in tariff in which there is a guarantee for the price that is above the market price for the producers. So the producers are encouraged to participate in the power market more and more. Next is the Renewable Purchase Obligations (RPO) was issued with the help of this 2003 Act. So it mandates that all electricity distribution licensees should purchase or produce a minimum specified quantity of their requirements from renewable energy sources. So minimum production was imposed on the producers, that if you are a producer, then you need to produce this minimum amount of renewable energy so that it can be promoted in our country. So you can say the first major initiatives was taken in Electricity Act in 2003. Now, if you can see further, the integrated energy policy in 2006 in our country. So, the Planning Commission of India from energy policies which integrated all source of energy with the aim of achieving sustainable development. So, what we could say, to build a strong network of grid connected power through renewables, subsidies were provided that ensured the maximum output power generation and profit from the proposed projects. So the subsidies were identified, the particular what you can say, the producers, and subsidies were provided to ensure the maximum power generation and to ensure the profit of the participants. Okay, so for promotion of wind power, especially a policy on utilizing a private land for setting a wind farm was also recommended. Okay, so it was recommended that the private land for setting up wind farms can be also taken uh, if we want to install the wind power with some uh, direction, with some what the policies was there, and we need to follow those policies. Next is the tradable tax rebate certificates, TTRCs, where there in 2006, and the capital subsidy on standalone system could be linked to earned benefits. Okay, so as a standalone system in rural areas could not be benefited by feed-in tariff policy. What can be found that the feed-in tariff that was imposed in 2003, it was not beneficial for the rural areas. Okay, so for especially for the rural areas, these TTRCs were developed uh, to promote this renewable energy sources. Next is initiative was the generation based incentive, that is called GBI. So in December 2009, the Ministry of Renewable Energy launched a scheme in which GBI at the rate of half rupees per unit wind electricity generation. Okay, so that is a kind of incentive for the per unit wind electricity generation, and the wind energy projects providing electricity to the grid. And one condition was imposed under this GBI. What was that condition? The wind energy projects providing electricity to the grid for minimum 4 years and maximum 10 years with a capital of rupees 1 crore per megawatt were to take advantage of this scheme. Okay, so this is for those who are meeting this particular criteria, they can take the benefit of this. Now, next in 2010, we can see the renewable energy certificates. It was introduced by CERC, Central Electricity Regulatory Commission, under the Electricity Act 2003. And what is the meaning of this certificate? It certified that the bearer of this certificate owns 1 megawatt hour of electricity generated from a renewable energy resource. So a new renewable market was formed in India through this REC trading, and enhancement of investment in renewable energy also hikes. Okay, so after these initiatives, if you can say the pattern of renewable energy growth in our country, then clearly you can see the growth, and it is visible also how it can be grown from the past to the modern uh, era. Okay, so this renewable energy certificates was sold, and it was purchased by the some means what you can say, and those who have purchased, then they are having the right of using 1 megawatt of energy generated from the renewable energy resources. Now, next is, if you can see in 2010-11, the National Clean Energy Fund was there. So, in Union Budget 10-11, considering the problems related with coal, NCEF was proposed in order to finance and support a clean energy drive in the nation. Okay, so an initiative that is Green Energy Corridor, you might have heard about this, was approved under the financing scheme of NCEF. Okay, and this Green Energy Corridor is to improve the interstate and intrastate electricity transmission by connecting the power generated by wind energy. So it is not only it is for the renewable energy based this corridor, and the wind energy is emphasizing here in GEC, and we can see these steps are the promoting steps for the wind energy in our country. Next, if you can see the National Wind Solar Hybrid Policy that that came in 2016, and it was found that wind and solar resources complement each other, and thus their hybridization would be helpful in achieving the better grid stability. Obviously, if as a researcher, if we are thinking for the hybrid wind and solar kind of things and its management while providing the power, then we can get a stable power in our uh, system. Okay, and we can use both of them. Okay, and we can stabilize and we can minimize the intermittency also when we are going for with the hybridized. Okay, so wind bidding is key. So why I am considering this particular point, that since it is associated with the electricity market, then this bidding scheme of this renewable energy sources are very important. So what is this? This scheme was sanctioned by MNRE in June 2016, according to which wind projects of 1 gigawatt capacity connected with central transmission utility were proposed to be set up by Government of India. Okay, so one capacity was demarcated, and if this capacity and that was to be set up by the Government of India. So, and another steps, the digitalization through the e-bidding option. So e-bidding options was introduced under this bidding, what you can say, the bidding scheme proposed in 2016. The transmission of wind generated electricity to least windy states. Okay, so least windy states are already identified, and the transmission of wind generated electricity, we need to transmit from the what most windy state towards the least windy states. So helping the wind states in achieving their RPO target from non-solar resources. Okay, so this was the scheme proposed in 2016. Now, policy for repowering of wind energy projects. This policy was introduced in 16, and the aim of the policy is to ensure the optimum use of wind resources by providing better framework for repowering. Okay, so these are the policies that were adopted by the government of India to promote the renewable energy sources, and especially some points I have especially mentioned for wind. So this wind energy is most important, and we need to take care, and we need to carry out further research works. And the major focused area of research, some of them I would like to mention here, like wind power prediction tools to improve forecasting for electricity production. Okay, so always the forecasting is a huge challenge when we are dealing with the intermittent wind energy production at the higher level, and we need to deal with this. So I told you in the previous slides also, this prediction tools, even the research has been carried out exhaustively for this particular topic, but still uh, we need to emphasize, we need to find out some optimum way or some efficient tools for predicting the things, and uh, so that it will be most efficient than the previous developed tools. Okay, so better forecast for wind power production potential reduces network system imbalances. As I told you, that this minimization of system imbalances, and in terms of its reflection in terms of cost, need to be maintained for better or healthy electricity market operations. Next is we can go for the modeling and grid simulation studies to develop management tools and practices to ensure grid system optimization. So obviously, this topic has been addressed, but uh, the research of any particular, means what you can say, the vital or major topic is still open, and we need to try from our side as a researcher to find out some efficient ways to model and to integrate this intermittent resources with the grid, and to manage the grid accordingly. Okay, next is the investigation and planning of designs to reinforce and extend the grid. Okay, so investigations are the major area. You can say, if we are proposing something from our side, uh, and we are going to implement, then the investigation, and we have to do a lot of planning for designing the things, so that our grid operations with this hybridized intermittent resources is most beneficial for the market participants, as well as what you can say up to the user end also. Okay, so the analysis and development of grid access rules, technical codes requirements, and international standards that we need to follow. Then we need to compare the things, and we need to emphasize on these particular issues. So here, one of the things that is to just focus towards mitigating the intermittency of this renewable energy based resources, that is the direct and indirect coupling of renewable energy resources with flexible load. That option is always open, and it requires a lot of research work, and then how this the flexible loads can be used to mitigate this intermittency behavior, and how to implement them, how to schedule them in our system so that not only the intermittency mitigation effort can be seen from the generation side, but it can be also seen from the another side, that is the load side. Okay, so this it focuses on utilizing demand side flexibility as a hedge against supply uncertainty caused by the inherent intermittency of renewable energy resources. Like I told you. So here the time flexible demand side resources could adopt their energy consumption according to the fluctuations of renewable power supply in order to buffer its variability and enable large scale integration. So obviously, if we would be able to mitigate this intermittency, then we would be able to what integrate more and more renewable energy resources safely in our system, and our system will be operating as a good system and cost effective system, green system. Okay, and it is a future of our uh, electricity sector. So such an approach may be implemented with existing technologies, is compatible with existing power system and power market operations, and is aligned with existing economic incentives. Obviously, if we could see the past tracks of economic incentives, uh, then we can go means not we from the top government side can do this, like this economic incentives for those who are participating and who are following, who are developing this kind of things. So what expected confront action uh, may be taken from our end as a researcher to develop an optimal strategies for direct coupling of flexible load between the resources in the context of a competitive electricity market. Okay, so whatever we are doing, we if we are doing in context of electricity market, then the financially or economically we will address the things also, apart from uh, the already existing technical mechanical things that we are doing from our side. The financial thing can be also did. So the simulation-based comparison of direct coupling of wind and flexible load versus centralized market approach based on price signals and load response may be done. Okay, so we have to whatever we can contribute from our side, we can go with the centralized system, and as a centralized system, we'll be able to deal with the system. Okay, so
Oh,
to
oh,
design
the
a
screen
smart
share.
charging algorithm for electric vehicles also, and to use a coupled wind power and spot market energy procurement. So, so the mitigation, so mitigating renewable intermittency through non-disruptive distributed load control. Okay, so what are the ways? What are the what you can say uh, the possible ways by which we'd be able to maintain the intermittency of the renewables that I'm trying to highlight here. Actually, apart from the conventional things, these things are also required when we can think for a better system. So it is simpler for the utility or aggregator to interact with a small number of large customers than a large number of a small customer. So obviously, the small number of large customers are required. So if so for that aggregations are required, and you can find so many research, so many means what are topics are related to the aggregations in the electricity market, and you can see how the aggregations are beneficial when we are going for the bulk amount of power to be integrated and bulk amount of power to be dealt, especially in the electricity market. So benefits for using aggregations of small this loads to provide more reliable responses than a small number of large loads. Then employ simple local controls, which facilitates faster responsiveness, easy to model for state estimation and control purposes. Okay, so what are the expected concerned action in this regard? So the resource cost and revenues analysis may allow to directly compare the capability of cost benefits of this thermostatically controlled loads to those of generators and energy storage devices. So energy storage devices, you can see, it is a vital things when we are thinking to mitigate the intermittency of renewable energy side, and still the research is going on to improve the energy storage devices and their uses in the electricity market. Okay, so you can say in terms of the many ancillary services in the electricity market, we'll be able to use the various what you can say the supports coming from the participants, and by which we'll be able to uh, uh, get the efficient operation market operations. Next is the probabilistic simulation of power system with integrated renewable, demand response, and storage resources. So obviously, these probabilistic tools need to be developed, uh, and so that we can uh, what consider the intermittency of the renewables considerably, and we'll be able to put our effort towards getting the balanced electricity market. So a computationally efficient probabilistic simulation tool need to be developed. The quantification of the economic, environmental, and reliability impacts in the simulation approach need to be carried out for varying levels of wind, solar, and demand response penetrations. Okay, and some appropriate stochastic model, because if you are dealing with the wind energy, then we need to develop the stochastic model, the stochastic prediction models for that. Okay, so that what if since we are dealing with the electricity market, so here the stochastic models plays a very important role here, and we need to develop the strategies based upon multi-level problems. Okay, multi-level problem, the problem, your complete problem from integration issues till your what you can say the economic benefit issues. We have to divide our problem into several stages, and we deal the problem stage by problem, and we can combine them together, and we can see as a whole. So, from a wholesale market perspective, system operators will be challenged to maintain adequate reserves that will be needed to meet increased variability and uncertainty to supply due to intermittency. Okay, obviously, the what we have discussed just now, that storage devices and other things we need to address. So system operators will need to upgrade their operating procedures to improved mathematical formulations and computational capabilities. So not, I told you earlier also, not this is not true for only for the system operators. This is true for the bulk participants also. If you are a bulk participant in the electricity market, then you need to develop your own strategy and procedure, so that you can cope with uh, the develop a strategy by the system operator, and you can be a good what participant for the market. So in stochastic programming model, uncertainties are expressed in terms of probabilistic scenarios, and decisions are divided into two steps. Like first, the investment decision must be committed to before the scenario realization is known. So we need to just go with the whatever the scenario, that is even the from good scenario up to the worst scenario. We need to realize all those scenarios, and then we need to proceed with our problems. Second, the operational decisions can take possibility depending on which scenario occurs. Okay, so we need to decide in our approach that how we can take, how we can address these scenarios in our model, so that we can get a good optimum way to get the profit for the market as well as its participant. Okay, so therefore the planning decisions required a bi-level structure their planning decisions in the upper level, anticipate market reactions in the lower level equilibrium among market participants. So the this bi-level structure I told
Sir,
you just
sir,
now. Yeah,
Tiwari sir.
yeah,
Hello. Sir,
yes,
sorry
yes.
to interrupt, sir. Sir, can you little bit work out with the audio? It feels like some interference from the nearby devices are there.
Okay,
Little bit with the audio, sir.
okay, okay, ma'am. Let me see. Now is it okay? Hello.
There are still some glitches, sir, that I can hear.
Okay.
It's audible, sir, but the thing is, little bit of glitches are there. Means it's not very, very clear.
Hello, hello. It is still there.
Okay, sir, we can hear you, sir. Please kindly go ahead, sir. No problem.
Okay. Okay. From a wholesale market perspective, system operators will be challenged to maintain adequate reserve, that we have already discussed, and we were discussing regarding the planning decisions requires a bi-level structure. So we have to divide our means problem into level wise, and we need to resolve the issues, and we need to solve them, and we need to combine them together. So what we can go the planning and market design for using dispatchable loads to meet renewable portfolio standards and emission reduction targets. So, uh, so what will happen here? The concerned major elements that can be seen. The identify the needs for different types of system services that we need to identify first. What kind of services are to be just required for the system that we need to identify, and then examine the engineering and economic feasibility of aggregating dispatchable loads. Okay, so feasibility is the another important issue when not only deregulated environment, but all conventional environment also, that the feasibility whatever we are going to use, the feasibility analysis for that must be checked. So this feasibility analysis will reflect us the correct path that we are going in the correct way. Okay, so to evaluate the performance of a unified market for multi-time scale system services, what happens here? The system operator may be rewarded with economically efficient ways to meet high penetration of renewables and emission reduction targets. Okay, so it comes under this what you can say uh, some kind of incentives that can be provided to the system operator for doing so. So aggregators may be rewarded by financial payments for providing system services, and dispatchable load owners will be rewarded by the lower cost for their energy services. All right. So uh, the reward kind of thing is already there, and it should be improved further also for increasing its reliability, and for mitigating the issues in the market. The expected impacts, what we can go, what we can think for that. The new market products can be developed for incorporating different demands, and current market designs and environmental quality may be improved. Okay, so we need to think in this area also. Now, regarding the deregulation, I will not discuss all these things because you all might have familiar with this, that about this deregulation. And in Indian scenario, only I will tell you, it was started in 1990s, okay, in India, and it is increasing year-wise as per our uh, previous discussion, and as per the various policies were adopted by the government of India in the past, and it is still improving it, and still it requires many what you can say the steps towards improving the same. So the regulated structure, since we are going with uh, the modern and we are discussing everything with the modern electricity market, then few points, 1 or 2 points at least, I would like to discuss here and compare this the conventional one with the deregulated one. So, if in terms of wind also, if you will consider the regulated electricity market or the previous electricity market and the deregulated electricity market, then how you can compare these two different things that in the previous or conventional electricity structure, or you can say the regulated structure of the system or the old structure of the system, there was monopoly. Okay, and due to that, uh, there was a difficult to uh, this you develop yourself as a owner of the renewable energy power, and you have to just come forward to feed it in the system. Okay, so there was no rewards, there was nothing, nothing was there, uh, and every was under control of the single entity. One company was dealt with this generation and transmission distribution facilities, and their decision makers are common. The single decision maker is there, and whatever has been decided from the top, it will be reflected till bottom, and it will be reciprocated up to end users also. So the customers are not having any opportunity to choose their provider in the regulated structure or old structure. That's why, if you will think this wind energy integration in that scenario, that was very difficult to come forward with a particular service. Okay, now if we will go with the deregulated structure, so here the competition has been involved, and main thing is that the monopoly will be discouraged. All right. So if monopoly will be discouraged and non-discriminatory approach will be promoted, then obviously you can say the system is good to participate and open to participate for a market participant as a producer or as a what you can say the retailer or demand side bulk customer. Okay, so what you can say here, the independent entity in this deregulated structure, uh, it has to take care all uh, the things, all the what you can say, the good things or bad things related with uh, the specific part of the power system, that is called the generation, transmission, and distribution. All have to split here, and from vertical integrated utility, uh, we have moved, or we are moving towards the horizontal uh, utilities. Okay, so this under this particular scenario, the trading of energy takes place between buyers and sellers, and both have to participate. Both are having the freedom under the specific rules and regulations framed by uh, the owner, system owner or operator, and it is also savings and cost effective pricing. As I told, that everybody is moving towards getting the profit. So an efficient way need to be developed from the market side, market operator, so that it is good in terms of cost for all kind of entities. So development of new and better services and more customer choices are there uh, in this particular new environment. So how you can provide the better service? 1 minute, please. Yeah, sorry. So the development of new and better service and more customer choices. So since the customers are being involved here in this deregulated structure, so they are having means what you can say, the freedom, and this freedom word is the very vital word here. it is to be used for the bulk uh, customers side, and they are free to choose their providers. Okay, so it is a flexible kind of thing, and flexible market structure is there, and it will encourage the competition, and competition encourage everything. Okay, like reliability, like what you can say, the quality, everything will be improved by this. So effective capacity planning and motivations for innovations, if the competition will be involved in the system, can be seen. Here, the same structure, the deregulated structure has been shown here. Here, if you can see, it has been splitted, as I told you in the earlier slide. The power flow route is same, okay, as previous. Power flow route is not being changed, okay, because even you are a system operator, or you are a retailer, or you are a customer, or you are a generator, you cannot place your own bulk own channel to transmit the power here, okay, for bulk power transfer. All right, so you have to use the existing channel for your power transmission, and the existing channel, but what can what it can be different from the regulated structure, that you can see the power is being transferred from here to here, but it can be dealt from somewhere. Okay, the dealing can be done at somewhere, and implementation can be done here. Okay, so we can see the different arrows are given here. This is for the energy flow from left to right, from generation to customer. Now the information flow, if you can see, uh, the information flow that can be directly from the retailer to the generator, okay, through this customers means customer to the generation also through this retailer, and this retailer will play a very important role in this deregulated structure. Every financial activities are being done here, and it has been finalizing here, and the rates and all these things with the help of this ISO system operator, and directly the system operator uh, can dealing this generation also. So if you can see, the customers are having these opportunities to uh, just decide their owner, means generation, and they can directly contract with this generators as a bilateral contracts. And uh, so whatever we are doing as a customer, and whatever we are doing as a generator, we need to look here and here. All right, because ultimately this site has to transfer to sell their powers to them, and through them. Okay, so this part is important in deregulated structure. Now if you can see this particular slide, then we can compare the things from the very old era to till new era. Okay, so if you can see here, in 1947 to 1998, the structure was like this, and here upstream and downstream monopoly were there. Okay, at the both side, from the generation side, from demand side, we could see the monopoly, and there is no room for competition here. Okay, but if you can see, from 1998 to 2003, we can see the upstream partial competition and downstream monopoly, complete monopoly. Okay, so you can see the number of generators, number of competitors has been involved, but what happens here, there is no competition in the here at the distribution side. Okay, so that's why what happened, the monopoly has been involved. And if you can see, the market power chances, market power activity was there in this two blocks of years. Okay, if you can see the market power, that the dominant power producer can affect the whole power system, and it can decide the price. Yeah, it will play the role to decide the price in the system. Okay, so that was involved here. Now, if you can see, in 2003 to 2050, the upstream competition can be seen and downstream partial competition could be seen. Okay, so here if you can see, the partial competition has been involved in the here at the distribution side also. Okay, and we have moved from single auction market or single auction system from double auction system partially. Okay, and if you can see, here 2015 onward, then here the upstream and downstream the perfect competitions can be seen. And here we can say, there is less political, what you can say, the influences, and more influences of the market activities, more influences of the behavior of the system participants, more influences on the quality of the, what you can say, the service providing to the system, or by the service provider, that are now promoted. And it is possible to get a power market, that is the balance from uh, generation side as well as demand side. Okay, so this is an indicator that how we have proceeded from the conventional towards the modern system. Now, the market clearing process, uh, we can see here the single and double auction mechanism. You might have familiar with this. Okay, so I will take this one. If your supply is flexible, and this is your staircase supply, what you can say, the curve, and this is your demand curve, that you can see. This is for the rigid demand. Demand is not being changed here, and it is fixed at a particular point. Then uh, how the market price can be decided, it will be completely determined by this supply offers, whether you have to shift it upward or you have to shift it downward. Okay, so the price will be the completely deciding factor from the supply side, since the demand is not having any role here. Okay, but if you will see the second one here, the double auction mechanism, in which what we have uh, seen here, the supply side was flexible and demand side was also flexible. So supply bids has been arranged in ascending order here in staircase manner, and demand bids are arranged here in descending order. Okay, and we need to decide uh, the market quantity, and what you can say, the market clearing volume and market clearing price. So MCP and MCB both come into the picture here, and we need to see the whole system surplus. This whole area, if you will see, this will be the whole system surplus, and if you can divide it into consumer surplus, and this is the production surplus. All right, so this kind of flexibility is there with the system operator to exercise its what power here, to go with this particular mechanism, and to decide some kind of uh, profit for the system. So the methods of auctioning in day ahead and real time markets. So what we were discussing here, uh, a day ahead electricity market or real time markets, both are having their own importance that we have discussed earlier. Here, I would like to discuss in short about the bidding mechanism, because if we are going to integrate our wind energy into the system, or any renewable energy into the system, or not only this, our hybrid systems with renewable and conventional also, then we will need a specific bidding mechanism. Okay, that's why you can see the research, an exhaustive research on bidding strategies. Okay, how uh, because if you are going to participate in a market as a producer, then what you will do from your side, you have to see that you have to track the market, and you have to see the data provided by the system operator at the regular basis, okay, even at the hourly basis, and you have to track that data at the open access platform, and you will have your own strategy to participate in the market, that is called the bidding strategy or your own strategy to participate in the market, and everything is concentrated towards getting the profit as your own. Okay, if you are a provider, then you will look for your profit, how you will be getting more and more profit if you will be participating in the market, and at the same time you will also think how much how what are the chances for the losses also. Okay, what can be happen, what are the possibilities for the losses in the future market, so that you can bear that losses also. Accordingly, you have to decide your own bidding strategy. Okay, so there are if you can see the two broad categories are there, that is called uniform pricing or discriminative pricing, or uniform bidding strategy or discriminative bidding strategy, or you can call it uh, 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 pay as bid. You might have heard about that, the pay as bid bidding strategy, that is coming as discriminative pricing, under discriminative pricing. So what we can say in the uniform pricing, that if in the previous diagram if you can see, if the price has been determined, both the curves are interacting here, and if we can see the price here, this will be the common price for all the market participants. Okay, so this is called the market clearing price, MCP, and everybody is bound to follow this MCP. That's why we are getting this surplus and this surplus. Okay, it is due to only this price. Okay, so the market participant, once the price has been determined centrally, it has to be followed by all the system operator, whether you are a consumer or whether you are producer. So what will happen, the price will be uniformly followed by consumer and production. So this kind of strategy is called what, the uniform pricing strategy. Okay, and there are several parts of uniform pricing strategy. The names are given here. I'm not going in depth here. You can go through that separately. So yeah, here, if you can discuss the bidding model based on double auction mechanism, then we have to see uh, these particular points. This is last accepted offer. What was the last accepted offer? What was the first rejected bid? What is the last accepted offer? Last accepted offer is where the offer cuts this demand curve, okay, and that is acceptable. Okay, this is the last accepted offer, and this FRB first rejected bid is here. Okay, after this particular point, all the bids has been rejected. Okay, similarly, other uniform pricing mechanism are also there that we need to take, and we can see what are the effects of those in the power markets. uh, Quickly, I will go through case study, like the economic risk-based bidding strategy for profit maximization of wind integrated day ahead and real-time double auction competitive power market, as we were discussing just now. Okay, so the kind of risk that we consider in this particular problem, that is called the economic risk. Okay, so ultimately what I told you earlier also, ultimately in the electricity market we have to look towards the economy, and if is there any risk in the economic side, then we have to deal it thoroughly, and we have to analyze it thoroughly to develop a perfect approach how to handle this particular situation in electricity markets. Okay, so here uh, what we have seen, the Y level optimization problem has been considered here. It includes the lower level as market clearance, cost minimization, and this is the conditional value at risk maximization. That is a tool by which you will be able to this is a probabilistic determination tool by which you will be able to decide the degree of risk in the electricity market. So here in this particular work, what has been done here, the several economic risk has been addressed. And what is that? In general, what we could do here, uh, we have we have taken what the locational marginal pricing of the system, okay, and we have seen the various kind of contingency, or we have considered the various kind of contingency, like generation removal, line removal, load changing. Okay, so all these contingencies have been taken into the consideration, and n number of scenarios had been formed based on those contingency, and those scenarios are considered here for getting the for analyzing the system, and we can see whether the market participants are having their own profit or their own losses. All right, we could also see what kind of bidding in this particular situation can be adopted, so that the particular market operator can be benefited economically. Okay, so what has been done here, we have uh, uh, just seen the contingencies, and based on those contingencies we have assessed what are the change in the locational marginal pricing of the particular bus for a particular system. Okay, and CVR has been calculated based on this change in the locational marginal pricing. Okay, and in terms of demand or in terms of generation, we have to see whether this LMP or locational marginal pricing is benefited for this particular generator, a particular producer or user or not. That we need to take care. And uh, this approach we have considered that, since it is a bi-level approach, then we have considered these two different, the left hand side. If you can see here, we can see the generated scenarios. As I told you, the many scenarios we have generated by considering different outages such as line generators, load, etc. Okay, then OPF we will consider, and after that we have to calculate locational marginal pricing at each bus, then calculate the CVR as I told you just now, and this CVR is based on the LMP at each bus. Okay, and by assessing the value of this CVAR, we have to assess which particular bus or which particular node is considered as the riskiest node. Okay, so what we will do here, we have to sort this CVR value in the ascending order, and when we are moving in a curve, this probabilistic curve, from what towards the positive side, then we can see the risk will be minimized. So what we will try to find here, the CVR value at the positive side. So when the CVR value we will get at the positive value, most positive value, it means we could what we had uh, decrease the risk in our system, and that risk is associated with this locational marginal pricing. It is directly located to the locational marginal pricing. So what once we will sort this the CVR value, then placement of different renewable sources such that wind considering risk nodes based on the CVR. So what we will do, the CVR value has been sorted, and we will choose to place the wind, and we have to see the feasibility also. Once we have sought it and we have found a particular node, then we have to see whether the wind to be placed at that particular node is feasible or not. When it is feasible, then we have to place it. Otherwise, we have to go to the next in the priority list, and then we have to check again for the feasibility, and we have to go ahead, and we have to check that whether the LMP change LMP is less than the old LMP for load buses, or is it greater than the old LMP for generator buses. I told you the LMP for the generators and LMP for the load are having their respective importance. As a generator, what you will do, you will try to get more price. Okay, so from the generator perspectives, your locational margin pricing will be something. And if you are a load and you are participating as a flexible load, then uh, as a load, you will try to bid and you will try to show your willingness to pay from your side, you will try to pay at the less cost. Okay, this is the what from the demand perspectives. So less price is required by the what customer, and high price is required by the producers. Okay, so accordingly we need to check it, and we need to go to the another loop for choosing the appropriate bidding strategy, and we need to check whether the profit is being maximized from the previous or not. And if it is not, then we can choose the different, we can change the bidding strategy, different bidding strategies, and then we come and we converge to a particular point so that we can get the profit is maximum or not. Okay, so for that we have done so many means results are given here. Here you can say this particular bidding strategy is beneficial in this particular case is for supplier, and this particular bidding strategy is for beneficial for the buyers also. So uh, this can be done. Okay, so for the real time as well as what you can say at the uh, day ahead basis. And here you can say the value of CVR, as I told you, if you are moving from positive to means negative towards positive value of this, then obviously we are decreasing the risk, and uh, by decreasing the risk we will be able to increase the wind penetration at a particular node in order to decrease the system prices and to reduce the conventional generation prices. Okay, so that was the theme of this particular work. Now I would like to stop my discussion here because it will take too much time to conclude all these things. So thank you all. I would like to actually, if you have any question, I would like to, I will happy to answer. Thank you, Risha ma'am.
Thank you, sir. So, from this lecture, we have learned a lot about the impact of wind power and electricity, importance of microgrid, wind demand forecast, demand and supply forecast. Some Indian policies also we had come around, and the different agencies that made those policies like MNRE, CERC, and GEC, and also found out some of the bidding schemes about that. And we also came across the model for electricity market, and finally we had ended up with few case studies. So thank you so much, sir, for such a elaborate and technical session on wind energy on the context of electricity market. So we have a few questions on the chat box, sir. Kindly, if you may take all those questions, and then we can move forward, sir.
Yeah, yeah. I can take what is ISO. So ISO, that is the independent system operator, and it is a backbone of electricity model, any competitive electricity model. What you can say here, uh, the system operator makes its own rule and regulation, and all other system participants need to obey that framed rules and regulation. Okay, so system operator takes care everything associated with the market activities that is beneficial to the market. Okay, in order to maintain its reliability issues or its efficiency, or how the system will be beneficial, everything will be taken by the system operator. Okay, so is it all right? So next, why demand is taken decreasing order and generation is increasing order? It can increase. Okay, actually, we are taking the random bits from all the generator sides or demand side, because in normal purchase, if you can see, if you are collecting a bit, then you are collecting from the various what you can say firms. You are collecting the bits, and what you will be doing, you will be arranging those bits from your side. So see, who will be doing this? This is the job of the system operator or ISO, who will be collect the bit from the generator from the demand, and they need to arrange them in the ascending or descending order. So the supply side, the generation bits need to be arranged in ascending order. Why? Because uh, uh, what you can see, the generation is from the customer perspective, the generate more generator at lesser price is most beneficial for the system. Okay, if someone which had bidded that, okay, 5 megawatt of electricity I will give you at this price, and someone has bidded the 5 megawatt electricity I will give you at the higher price, so which one you will choose? You have to choose at the lesser one. Okay, so that's why you will start from the bottom, you will start from the lesser price block, and you will go in the upward direction. That's why the supply curve is arranged into the ascending order. Like demand, demand, what you will be doing, what is beneficial for the market as a demand, what you want to do, you want to give less amount for purchase anything. If suppose you are going to purchase anything as a customer, what you will try, you will try to get at the lesser cost. Okay, so you will bargain the things and you will make it just lesser. Okay, but as a demand, if you agreed to pay more amount, okay, so that is good for the supplier now. If you agreed to pay more amount for a particular commodity, then it is good for the supplier perspectives. So that's why those demand who have bidded highest price for the particular demand, they will kept at the first at the highest side, and then it will be decreasing step by step. That's why it is in decreasing order. All right, so this was another question, and so many questions are there. uh, do consumers have, yeah, so what I suggest, if you are having any other questions, then you can directly write to me on my mail id, and you can clear from there also. But here, do customers have a choice to select their retailers? Yes, obviously, the retailers are actually, if you are a bulk customer, if you are a bulk customer, then only you have influence in the market. All right. But if you are not a bulk customer, you are a small customer, then you may not have such choice to directly choose to a provider. Okay. So this opportunity is open for the bulk customers. Okay, I think it's okay. Okay, ma'am, over from my side. And
Thank you,
if
sir.
they are having any other question, I am writing my email ID here. You can directly write to me. Uh, yeah, it is available in the chat box. You can write to me. Okay, thank you. Over to you, Risa, ma'am.
Thank Yes, thank you so much, sir. It was quite a interactive session, sir. It was interesting too. Thank you so much for joining with us, sir. It's a pleasure hearing from you. Thank you
Thank,
so much, sir.
thank you for the organizers for inviting me for this particular discussion. Uh, Especially for Risha ma'am, Nilul Sinha sir, and other two coordinators, Swapna ma'am and Sujit sir, and uh, to all participants also, those who have listened very carefully this lecture. and actually this everything is open for the research, so you can go for that and you can get more benefited from that particular area. Okay, thank you from my side. Thank you very much.
Thank you, sir. Pleasure is all ours, sir. Thank you so much.